Well, good morning, good afternoon, or good evening as the case may be. My name is Steve Greb, and I'm the director of AquaWatch, the Water Quality Initiative. I want to start by thanking the organizers in the GeoSec office for the opportunity to speak to you today. And what I want to share with you today are some of the activities that AquaWatch is involved with respect to ensuring confidence of Earth observation data in products. So I'm not going to talk about AquaWatch per se. Suffice to say that AquaWatch has 5 components all along the data flow, and the 2 that we're most interested in are the observations and data and products and information that we're going to be talking about today. Each of these 5 circles that are on this diagram have working groups that are supporting these activities. So just a little context for the presentation. We all know that there's a lot of Earth imagery being generated every day, and that a lot of it is underutilized. And we're seeing more and more that particularly satellite Earth observations can have a significant impact on the framing and the driving changes in policies and in management practices. I would also say that what we're talking about here today is applicable to other GEO initiatives. And I see this as foundational work in support of GEO strategic plan. And though I might touch on the engagement priorities, and probably won't focus on them too much, but this is important, again, background or foundational work which will support the engagement priorities. I also want to recognize the principles that have previously been described by the quality assurance for Earth observations that we're following. And I think one of the important take-home messages here is we need to build trust and success stories with the end user community. In a recent paper by Schaefer et al., in which they surveyed a number of water quality managers, as in the box here, it says almost unanimously, interviewees wanted assurance that the satellite product could be validated and include reported accuracy or error estimates for their particular water bodies. And that they agree that if a product was proved to provide an accurate measure of their particular water body of interest, they would be open to using these products for monitoring, research, and assessment. So the slide that I'm displaying here now, these are 6 platforms or data sources, if you will, that you can find on the web right now, which are a source of water quality data, either the UNESCO Water Quality Portal, NOAA's Ocean Color site, or the Copernicus Global Land Service, which has a lake water quality tab there. And a number of the data cube efforts that are going on. So they're all producing water quality data that can be accessed. Some of the issues are that these different approaches or different entities could use different sensors, different time periods, different product processing, which is really important, have different degrees of validation, and some are open source, some are proprietary. The bottom line is there could be conflicting results from these different products for the same time and location. Hence the concern about trust from the end user. So what is AquaWatch doing to help strengthen the confidence in Earth observation water quality data sets? So 3 things that we're currently working on that I want to touch on today. One is working on Aquatic Analysis Ready Data. Second is the building of global data sets. And third is the coordination of a global validation effort. All these play a key role in the development of the Knowledge Hub, which is really one of our primary focuses. And they contribute to the GEOS data management principles in the need for common standards and interoperability arrangements. So all this work, I'm going to talk first about the Aquatic Analysis Ready Data, and this work is being done collaboratively with CEOS. and some of the entities within CIAS, namely the Working Group on Information Systems and Services, the Land Surface Imaging Virtual Constellation, and the Working Group on Calibration and Validation. And you can see all three of these in their goal statements have language that are in support of the group on Earth observations. And it's been a great experience working with them. So what is analysis ready data? CS defines it as satellite data that has been processed to a minimum set of requirements and organized into a form that allows immediate analysis with a minimum of additional user effort and interoperability, both through time and with other data sets. And that's an important definition. So CS has been involved in three, should we say, other parameters that they've completed now, what they call their product family specifications. And this would be the land surface reflectance, surface temperature, and normalized backscatter. And now they're working on two other additional parameters. The second of which is the aquatic reflectance, which is what our interest is here. Aquatic reflectance, you could say, is our currency, is kind of our starting point in which we use reflectance to build our algorithms or models which relate the satellite signal to a parameter of interest, say the concentration of chlorophyll. And the third point is this ARD is no longer a desire of the global users, but is now becoming a requirement and an expectation. So why do we need ARD? It increases the use and impact of satellite data and removes the data preparation burden for less experienced data users. So again, this plays an important role when we think about the Knowledge Hub. And it promotes data quality and consistency through defined specifications, these product family specifications I talked about. And maybe more importantly, it enables improved interoperability due to consistent specifications across different data sets in time. Why do we need an aquatic specific ARD? Well, of course, we all know there's been an increased interest in water quality from space, such as SDG 6.6.1. And currently, many users are trying to apply water quality algorithms to the land surface products. And this isn't an accurate process. The water gradient signal is much smaller than the land signal, and because of that, there's special atmospheric correction and things like adjacency effect, surface corrections that must be adjusted specifically for water targets. And this aquatic ARD product for Landsat and Sentinel-2 is going to help the user community and improve the science products. So what is AquaWatch doing with respect to ARD? So we held a global community discussion on May 20th, just a few weeks ago. Coming out of that, we're forming an aquatic ARD working group, and we're going to hold the next meeting in early July. Things we're going to talk about are developing a community consensus on the ARD aquatic product family specifications, the PFS as they call it, and what are the community needs. The other thing we're going to talk about is essential climate variables. This is from GCOS, and these are important in understanding our changing climate and the cycling of carbon and the impact on water bodies. Thirdly, the use of the new CIAS Coast study team as a vehicle to advance these products. And I'm just going to divert for 1 minute and talk about CIAS Coastal Observations and Applications Study Team, which is what the acronym COAST stands for. So the CIAS Coast is this coastal strategy for CIAS and helps facilitate engagement with key stakeholders. It's going to bring together and integrate a wide array of both land and water products to help us understand the interactions and dynamics at this important interface. And we're going to do this by building pilots at locations around the globe. ARD was going to play an important role in this effort. So this is an exciting new effort which is just starting up, and I'm sure you're going to hear more about it. The second thing um, that AquaWatch is involved with respect um, to ensuring quality data, we're going to compile global data sets, both in situ and satellite remote sense data. AquaWatch has been involved with, again, compiling a data inventory, and we're going to put this into the Real Earth portal, which is housed here at the University of Wisconsin-Madison. And this will also be embedded seamlessly into the AquaWatch website and linked to GEOS. And it's going to bring together data of varying file formats, naming conventions and columns, and transforming it into one cohesive data set. So we can compare these data sets as the issue that I previously had brought up. So it'll bring together Greb samples, buoy data, satellite products as example. And it also have visual displays, be able to produce time series and scroll across to look at sources for data comparison. And this is going to be updated hourly. We're hoping to start this work by the 1st of July of this year. And the last thing we're doing that we're excited about is we're going to hold a validation workshop. We applied for a NASA grant in December of this past year. It was awarded this spring. Due to the COVID crisis, we're unable to hold the workshop, which is slated to be held here in Madison, Wisconsin. So the workshop itself is being delayed till June of 2021. The goal of this workshop is to build a global scale validation network. And the workshop is going to cover a number of aspects related to validation. I'm not going to go through all these, but suffice to say that it is going to bring experts together from both the remote sensing and the in situ community. There's a number of workshop objectives, including looking at what are the current validation activities and identify gaps in the spatial coverage, look at the state of the current in situ and lab optical measurements, as well as satellite measurements in terms of representativeness for coastal and inland waters, and also spend quite a bit of time on the current optical and water quality databases, including the repository archive, the preservation, the provenance, which is quite important, critical, the stewardship, and the access to this data. And then finally, as I started to talk about as part of our goal, we want to build global coordination through international partnerships for validation activities. So in summary, there's multiple streams of water quality data products generated on a daily basis. There's multiple approaches and methods used to generate satellite Earth observation data, and they all have varying degrees of validation. And as we're seeing, there's critical quality assurance issues that need to be addressed for end user trust and successful uptake of these valuable data products. And finally, AquaWatch is providing an important platform and forum at this critical time to address these data quality needs. So I'll quit there. This has our contact information. If you have questions specific to these activities that I've talked about and discussed today, feel free to reach out to me, or if you have general questions about AquaWatch or want to get involved. So thank you.